I have a few examples to show you all of how to graph quadratic functions, and just a quick reminder that we'll be looking at quadratic functions that are being graphed in one of three ways. So those three ways would be vertex form. Our example from our summer packet was this. It's a vertex form, or we could have intercept form, or we could have standard form. And standard form is that y equals ax squared plus bx plus c. So all of these are things that you could be required to graph. Okay, so first of all, the first one that's probably going to be the easiest to graph is this vertex form right here. It's easy to identify the vertex and the axis of symmetry. Our vertex here is at 1, 5, showing up as the opposite of the value that is inside the parentheses with x, and it is whatever is added outside. The axis of symmetry, I'm just going to abbreviate as AOS. Please be sure that you're writing x equals 1 because this is a vertical line. So I'm going to do my vertex here at 1, 5. And there's my vertex. I'm going to draw my axis of symmetry. That is that mirror line. And I'm going to then graph a couple extra points. Now it's easiest to do this with a table. 1, 5, I notice that this is going to be opening down. If I use 2, then I have 2 minus 1 is 1, and 1 squared is 1, negative 1, so that's 4. So my next point would be 2, 4. Here that is. And if I use my mirror point, then I would have 0, also 4. So that's a pretty easy way to do this. Get my nice symmetric parabola. This is rather poorly drawn, but you get the idea. So that's the vertex form of the parabola. Now, my next form is going to be this one here. This is the intercept form. It's a little bit harder to find the vertex, but I do have my intercepts right here. So that's going to be very helpful to me because I have my x-intercepts for this, so I can go ahead and determine right away that I have 2 points on this parabola, and those points are going to be 1, 0. So if I substitute 1 in here, for x, I get 0 for y, and also negative 3, 0. So that tells me that my vertex is going to be at the point that is in the midpoint, or the mean of the arithmetic mean of 1 and negative 3. So that would be at negative 1. So I'll go ahead and just evaluate this function for negative 1 plus 3, and negative 1 minus 1. So that's going to be negative 1 plus 3 is 2, times negative 2 is negative 4, and then times 8, that's overall going to be negative 8. That makes sense. This is a parabola that's opening up. It is going to be horizontally compressed because of that positive 2. So creating this table, giving me the vertex, is going to give me some help right there. So my vertex is at negative 1, 8. I'm going to put my table into a little space of its own over here. My axis of symmetry is, of course, at x equals negative 1. There that is. And I'm going to take my eraser and just fix this because, of course, I put that line in exactly the wrong place. So I want to have this actually way down here so I can And there's my graph. This should have been at -8. I just graphed this upside down. This is great that I can just keep undoing. Let me graph that correctly at -1, -8, which is why I shouldn't be talking and graphing at the same time. Okay, there we go. And there's my key points. You'll notice how much narrower this is from that 2. So my axis of symmetry, once again, is at x equals -1. There's my key points, my x-intercepts or zeros or roots of the function, my axis of symmetry, and my vertex at -1, -8. So worthwhile just to check as you're graphing. If you graph a point wrong and you get something that is not a parabola shape, or you know it should be opening up and you're having it open down, you probably did something wrong, just like I did here. So let me go away from my pen tool and over to my arrow, and let me see if I can move this. Okay. And move this up so we can see here our final function. Okay, and this is in ax squared plus by plus c. So I'm going to determine the x coordinate of the vertex using x equals the opposite of b over 2a. So that's going to be over 4/3. And that would give me an x coordinate of 9/4. So right away, my axis of symmetry is at x equals 9/4. So I can go ahead and determine the y coordinate of my vertex by substituting in that 9/4 for x. So I'm just going to do a little bit of work right now. Y, or f of x, is equal to 2/3 times 9/4 squared minus 3 times 9/4 plus 6. And if you love fractions, you'll love this problem. We have 2 times 81 over 48. Just going to write 3 times 16. 2 times 81, and this will clean up a little bit. To 27/8, and that's minus 27/4 plus 6, and 6 is, of course, 48/8. So I'm just going to rewrite all of these with the same denominator. So this is 54/8, and I have 27/8 minus 54/8 plus 48/8. So 27 minus 54 is -27, plus 48 is +21/8, and that is going to give me my y coordinate for my vertex of 21/8. And that's approximately, that's going to be 2 6/8, 2 5/8, actually. So when I graph this by hand, it's going to be a little bit under 3. So my vertex 9/4 and 21/8. This is, again, a function that's going to open up. 9/4 is 2.25. So that's going to be right about here for my vertex. And what I know about this function is that it has a y-intercept at 0, 6. So what I can do to get that reflection my apologies for this hot mess of a graph, is to just reflect directly across the axis of symmetry. So 2.25 units on the other side would bring us to, there's 0.75, 1.75, and another 0.5 would bring us to 4.5, comma 6. And there is our parabola. So there's a couple of key points there, 4.5, comma 6, 0, comma 6, and there's my vertex 9/4, comma 21/8.